This video explains how to derive Hardy-Weinberg calculations and why they are used. So to start off with, in genetics you have traits that are determined by alleles, and you can have a dominant allele as represented by the letter P, or a recessive allele, which we show with the letter Q. When we are looking at populations of organisms, we often want to know the frequencies of the alleles P and Q, and one way we can determine this is through the genotype, or the genetic makeup of the population, or the phenotype, which is the visible characteristics of the population. The genotype can help us to determine what proportion of the population is homozygous dominant, heterozygous, or homozygous recessive. The phenotype, on the other hand, only allows us to see whether or not the animals portray the dominant or the recessive allele, so we cannot determine whether or not animals are homozygous dominant, heterozygous, or homozygous recessive based off their phenotype. So the first Hardy-Weinberg equation that we have to understand is that P plus Q equals 1, where P represents the proportion of the population that has the dominant allele, and Q represents the proportion of the population that has the recessive allele. For example, you could say that 60% of your population has the P allele, and then the other 40% of your population has a Q allele, so that added up together is equal to 1. The next equation is P squared plus 2PQ plus Q squared is equal to 1. And this can help us to determine the proportions of genotypes in the population, such as what percent of the population is homozygous dominant, what proportion is heterozygous, and what proportion is recessive. Now, as I mentioned earlier, we cannot determine the genotypes of organisms based off their phenotypes alone, because the dominant allele will mask the recessive allele, and therefore we cannot tell the difference between heterozygous and homozygous dominant. However, if we know what percent of the population is homozygous recessive, we can figure out the rest of the equation. For example, if we know that 16% of a population is homozygous recessive, we can figure out what proportion of the population has the recessive allele. And we do this by square rooting both sides to get Q is equal to 0.4. Now we must reference the equation we showed in the previous slide, where P plus Q is equal to 1. And therefore we just plug in P with 0.4, and we find that P is equal to 0.6, which means that 60% of our population has the dominant allele. It's important to note here that while 40% of the population has the recessive allele and 60% of the population has the dominant allele, this does not mean that 60% of the population shows the dominant allele or that 40% of the population shows the recessive allele. That's what this equation allows us to figure out. And now we can figure out what proportion of the population shows the dominant allele by squaring P to get 36, or 36%. So now we know that 36% of the population is homozygous dominant. Now, to determine what proportion of the population is heterozygous, we simply have to plug in P and Q to get 0.48. So this means that 48% of our population is heterozygous. Now, to check if our answers are correct, we can see if everything adds up to 1. So 0.48 for our heterozygous organisms, plus 0.36 for our homozygous dominant organisms, plus 0.16 for our homozygous recessive organisms is equal to 1. And that's how you solve for Hardy-Weinberg calculations.